Hello everyone. So this is a follow-up video on the earlier tutorial that I put up about connecting Node applications to a Postgres database using Docker. So in this tutorial, what we're going to go over is some terminal commands that are useful when working with Docker. So for example, if you're in an external host environment and you just want to tweak around a little bit with your containers, some of these commands might be very useful. From our last video, we learned that Docker is a platform for developers and system admins to deploy, to develop, and also to run applications with containers, and essentially cross-platform. It contains container technology and runtimes, as well as very useful virtual networking tools. So we created a Docker file for building the application and a Docker Compose file for running our script in order to get our applications running. But we didn't really talk about the intricacies of Docker, so this is what this video is going to be for. If you'd like to take a look at our previous video, I'll leave a link down in the description below. All right, so let's dive right in. So here we are on our desktop. And as we said last time, if you navigate over to docker.com, you should be able to download an application that is for your computer. And when you install it, you should be able to get a Docker desktop program that has a UI that looks something like this. So you can see that we have images, we have containers, we have local, and we also have hub. And if you navigate over to hub.docker.com, you can create an account. And in that account, you can actually store all of the images that you create. So the Docker workflow is something like this. We first start on the Docker Hub and we pull an image from the Docker Hub. Now the Docker Hub contains repositories that are created by myself, but also from other organizations and other people that are associated with the repository. So they contain images like Ubuntu, like Node, like Postgres, and so on. So these are all pieces of software that we can run locally on our machine. And when we run this image, it becomes a container, and it becomes a running container, which is dynamic. So we can add things to this container, like our work, like our code, for example. We can put it in there and alter this container. And as soon as we stop this container, it becomes a stopped container. And this stopped container can be the basis for a new image that we can commit to our local machine. And finally, we can push this image back to Docker Hub so that we can use it for another purpose. All right, so let's take a look at how all of this works. So the first thing we'll do is we'll do a Docker images just to show you that right now we don't have any images on our machine. And if we do a Docker PS, this will also show you that there are no containers running currently on our local machine. So the first thing we'll do is let's do a Docker run, and we'll run Ubuntu latest. Okay, so this refers to the image, and this refers to the tag associated with that image. So there could be a latest Ubuntu, there can be a Ubuntu 18, a Ubuntu 14, and so on. So as soon as we do this, it'll say that we don't have a local image Ubuntu, right? So what it's going to do is actually pull from this repository. So right now you see that it's actually downloading. And right now we have this image that is local that we can use. So if we do a Docker images again, you'll see that this Ubuntu image is now on our local machine. And there's an image ID associated with it. And there's also a size associated with it. I want you to note the size. The size is actually quite small because the way that Docker records these images is that it records just changes that are made from image to image, but also it gives you the least amount of libraries, least amount of resources that you're going to need in order to run Ubuntu. So in reality, it's actually very small. All right, so the next thing we can check is let's check the containers. So because we said when we do a Docker run, right, when we do a run, we're essentially pulling this image and actually running it as a container. So let's check out the containers. You'll see that we still don't have any containers. So what happened? Well, essentially what happened is if we do a Docker ps-a, you'll see that what happened is actually we did run a container. We were given a container ID, but it exited. Okay, so it did run Ubuntu, but because there were no further commands, then it just stopped. Okay, so it's so Docker, it gives us a container ID, but it also gives us a kind of human readable name that we can access and we can use for other purposes as well. All right, so let's get rid of this because an exited container is really useless to us. So we can actually do a Docker remove, and then we'll refer to the name of this thing. Okay, so we just copy down the name, and this will delete it. And so when we do a Docker ps-a, this will show us that we have no more containers left. All right, so the next thing we want to do is let's make some alterations to this container. So because last time when we did the run, right? So when we did the run Ubuntu latest, we didn't actually give it further commands. So this time I'm just going to do an interactive terminal. So this interactive terminal, it's going to run bash, and so it's going to wait for me to actually give it more commands. So when we go in here, you'll see that we're given a new terminal, which is labeled root, and we're also given this ID, right, which is the container that is currently running, that we're currently in. So now if you think about the workflow, we're actually in a dynamic and running container, and we can make alterations. So we can go into here and, well, first of all, let's take a look at where we are. So you can see that we're in the root of Ubuntu. So we have all of these folders available to us. And let's just do a touch big file. And this big file is, let's pretend it's just some code that we wrote. And so now this big file exists within this container. All right, so let's say I'm happy with this container, and I'm going to do an exit. And as soon as I exit, this becomes a stopped container in our workflow. Okay, so now if we take a look at our Docker ps all, right, we can see that there is this container that we were running, right? So notice that this is the ID that we're given, and we're given another name, right? This is not the same one anymore. This is another container, and it exited about 8 seconds ago, but I did make some alterations there. Now, the next logical question that you might have is, well, how do I get back into this container? What if I wanted to make an alteration to big file, or I wanted to copy more files into this container? And the answer is, unfortunately, we cannot, right? Each container, when it's stopped, it becomes a snapshot, right? So it becomes a basis for another image that we can create. So just to show you what I mean by this, if we do a Docker run again, and actually, let's run this command again, right? This time I'm taking the image Ubuntu, and I'm running this. Now I want you to notice that I'm getting a whole separate container ID, right? So this ID is totally different now. And if we take a look at what's inside, you can see that there's actually nothing inside, right? So no big file inside. It's because we are starting from that stopped image that was called Ubuntu, and we're starting afresh. Okay, so let's exit this. And I want to actually get rid of this Docker container so that we don't confuse ourselves. Okay, so you see that this was the latest one that we ran, and I want to actually get rid of this. Okay, so we'll do Docker remove this image. Okay, and so the only image that we have left currently is this one that contained our big file in there. Okay, so what's the next part in our workflow? Well, our next part in our workflow is that we were happy with big file, and so I should snapshot it. And this is a commit of the container. So if we do this again, and we can see that this is our container ID. It also gave us a name. We can take either of these things and we can commit it. So we can do a Docker commit. Now notice the very similar commands to Git, right? So this is actually very similar to the Git workflow as well. So I'm going to commit this container ID, and let's call it my big file. Okay, so I've made some alterations to it. I want to label it as some new image, and so it's going to give us a hash after this is done. And if we take a look at the images that we have currently, you'll see that we've created a my big file. Right? So we started from Ubuntu, and now it's called my big file. Okay, great. So let's say at this point I don't need Ubuntu anymore. Okay, so it's always a good idea to kind of just get rid of things if we don't need it. So I'm going to do a Docker remove this Ubuntu latest. Okay, so I no longer need this, so I'm just going to remove it. Oh, yes. So the reason why I'm getting this is because if we take a look at our Docker ps, this container, which is still kind of lingering, is based off of our Ubuntu image. So the conflict that it was giving me was that, yeah, there's a container that's currently running this image. Are you sure you want to get rid of this image? So I will actually get rid of both of these things. So I will do a Docker remove, and then this container ID. So I'm no longer running this container ID. And then I'm going to do a Docker remove image, this Ubuntu latest. All right, so I hope this is clear on what's happening. So if we do a Docker images now, you can see that the only thing that's surviving is my big file. So that is an image that I have locally on my computer. All right, so now let's run this my big file again, and let's add a few more things to this. Now you might be saying, oh, okay, so I can actually go in there and run a container. What if I actually want to keep it running and I never want it to stop, or I want it just to I want it to run, but I want to do something in my local host, in my local computer. So what could we do in those cases? So I'm going to do a Docker run. I'm going to do the my big file image. So I'm going to run my big file, but this time I'm going to run a terminal, interactive terminal, and I'm going to detach it. Okay, so you can see that we're actually running something aside from this container. So you can see that if we go to docker ps-a, it will show us that I'm running this image, my big file, right? And it's the status is that it is currently up, right? So it's up for 13 seconds. So detached means that it's running in the background and I have access to it, but it's not that it's going to be a stopped image. It's actually it actually is it keeps going. It's still dynamic. Okay, so if we ever wanted to connect to this image, we can go to docker attach. Okay, so the docker attach command says, okay, I have this image that is running, or this container that is running. I want to attach myself to it. So I'm going to just take this name, or I can take the container ID, and I want to attach myself to that container. So you see now we're inside of that container, and we can see that, oh, we have big file. Let's say I have another file, big file 2, that I put in here. Right? So I make some more alterations to this running container. Now at this point, let's say, oh, I want to be able to jump back into our terminal, right, into our local computer, right, and not be in this container. We can do Control P, Control Q. Okay, so Control P followed by Control Q is going to get us back into the real world, the local machine that I have. If we do a very quick check on docker ps-a, you can see that this container is still running, right? It's been up for about a minute, and I've been going in there and making alterations. Okay, so at some point, I might be done with this, and I can actually make it back into an image. I can commit it back into an image. So let's do that. I'm going to attach myself back in here, and I'm going to run the command exit. So as soon as I do an exit, this container becomes stopped, and now it is a candidate to be committed. So I can do a docker commit, and I'm going to commit this sleepy cray, and I'm going to make a new image out of this. So this is, I'm going to say my big file, and I'm going to tag it as final. All right, so this is the final version. So the tag could be anything that you want, version 1, version 2, whatever, right? So I'm going to tag it, and it's going to give me this feedback. Now, let's take a look, Docker images. Okay, you can see that we have a my big file, which is tagged as final. We also have a my big file, which is tagged as latest. Now, obviously, I don't want those things to conflict. I don't want to confuse myself. So I'm going to do a docker remove and the sleepy cray. So I'm going to remove this container. And I'm also going to docker remove the image, my big file, and then the tag is latest. Okay, so I want to remove that, and let's take a look at what we have. So if we take a look at our images, now the only thing that survives is my big file and final. Okay, great. So now we have something like this. Now the final step in our workflow is that we want to push it back into the Docker Hub, back into somewhere that on the internet we're able to retrieve that image, because right now everything is happening locally. So let's say I'm happy with my big file and the final version of this. Okay, so I'm going to first do a Docker login. So when we do a Docker login, I'm going to supply it with a username. So my username is BobbyCTChan, and I'm going to give it my password, which I hope is correct. Okay, so I'm going to give it the password. This is the password that I use to create an account on Docker Hub. And now I'm going to tag the image that I currently have. So I'm going to do a Docker tag. I'm going to tag it as, so I'm going to take my, what did it call? My big file. Okay, and I'm going to tag it as BobbyCTChan / my big file. All right, now it's a good idea to always append or prepend your username / and then whatever you want to call your image, just because you don't want to clash on the Docker Hub, right? So you're not allowed to choose a name that's already in existence. So it's a good idea just to prepend your ID to this. All right, I'm also going to call this, I don't know, the final version of my big file. Okay, so again, the tag is really up to you what you want to call it. Okay. Oh, whoops! I forgot that I tagged it as final. Okay, so we need to make sure that our tag matches with the image that we have. All right, so now we've tagged it, and now we're going to do a Docker push BobbyCTChan / my big file, and then our final. Okay, so this is going to do a push up to the Docker Hub. All right, so we're going to wait a little bit for it to be done. All right, so about 30 seconds later, you will get this feedback of this hash that says it's successful. If we take a look at our Docker Hub at this point, or even in our Docker desktop, we should be able to see that we have now that image there. Okay, so from now on, if I'm on a different computer, so let's do a Docker remove image, and this my big file final. Okay, we can see that in our Docker images, we have nothing. So I can do a Docker run, and then I'm going to pull from this repository. So bobbyctchan, my big file, and then final. So you can see that it's not locally on my computer, and so it's going to the Docker Hub, and it's pulling this file or this image so that we can run it. Okay, so that's basically the process of what is happening, right? So this is how Docker can be able to transport an app that is very large from one location to another just by doing these run operations and setting up the Docker daemon on a different host. All right, so next let's talk about virtual networks in Docker. So Docker offers a really high variety of networking options that can connect Docker containers to each other, as well as your local host to the Docker containers. So the purpose is for getting data into and out of the system as a whole. So Docker actually allows you to expose certain ports that we can use these ports in order to connect to the different containers that are running. So in order to show you this, let's bring up a container very quickly. So we'll do a Docker run, and we will run an image. Oh, by the way, I wanted to point out that these images, you can remove them by hand, or you can throw a flag RM in there that says, as soon as this container exits, I want you to automatically delete this image. So this is the flag that I'm going to throw in there. I'm going to have an interactive terminal, and I'm going to throw a P flag in there as well, which signifies the port. Now, what we saw in the last video was we had port 8081 pipe into port 8080. And as we said, whenever we see this colon notation, this thing is local to my machine. So this is on my Mac, and this is in my container. So this is the port 8080 that is transported from port 8081 in my local host. I'll show you what that looks like in 1 second. I'm just going to show you a few more flags while we're here. I can name this something. So this is, I guess this is, we'll call this my web app. Really, this is not my web app, but I just want to show you how this networking goes if this was a web app. And then finally, I want to run the image Ubuntu, and I want to grab 14.04. Now, there's a reason for me to grab this, because 14.04 is where there is a utility called Netcat. And basically Netcat is a computer networking utility for reading from and writing to a network. So this is how we can test how this virtual network actually happens. All right, so this is downloading the container right now. And as soon as we get inside of this container, I'm going to run a netcat command. Okay, so I'm going to run netcat nc, and I'm going to do an lp, which is going to listen for the port 8080. All right, so this is going to listen only for the port 8080. Okay, and now it's listening. So anything that comes in to the port 8080, it will kind of just regurgitate it. All right, I'm going to open up a new terminal here just to make this a little bit bigger. And this is my local machine. This is my local host. So my local host also has netcat. So I'm just going to run netcat and localhost 8081. All right, so when we do this, you can see that we have something that I can enter here, and it can be piped into port 8080. Now, if you remember what we did in our last video, we basically gave some kind of request. So let's say I send a request on localhost for a get operation and then home, right? So this is kind of like putting it into our browser, right? So this request is going to be piped into port 8080. And you can see that's exactly what it's being displayed, right? So whatever we type here, right, in port 8081 on localhost is going to now be piped in to port 8080 in this container, right? So you can see that that is basically the virtual network at work for Docker. All right, so let's cancel out of here, and we'll exit this container here. All right, so maybe one last thing that I want to very quickly look at is volumes. All right, so if we take a look at what is available here, maybe I can just create a very quick folder. So let's do a make dir and my volume. All right, so I'm gonna have this volume here, which is something that I want to share with the application. So if we go into my volume and we just create a simple file. Okay, so file1.data. Okay, maybe I'll do a file2.data. Okay, and we can see that these are the files that are available to me, right, in my local computer, in my Mac. All right, so the first thing we'll do here is let's check our path, and our path is user/bobbyc/myvol. Okay, so we're going to do a Docker run, and I'm still going to do an interactive terminal, and this time I'm going to throw a flag -v, and -v is for volume, and so the first part of my volume is going to refer to the folder that I want to give it. Okay, and then I'm going to do a colon, and then it's going to end up in some folder in my container. So we'll just say shared folder, right? And I'm going to run Ubuntu 14.04, and let's run bash. All right, so if we take a look at this, this will bring us into the container. And now if we take a look at what's here, there should be a folder called shared folder. Okay, so I'm going to go into our shared folder, and if we take a look at the files that are inside shared folder, we should have the file1.data, file2.data. Right? So any manipulation that we create in here, right? So I don't think I have any tools to manipulate it, but so let's say we have a file3.data, right? Anything that we do here is going to affect the outside world. So if we go back to here, we take a look at my volume. This is my MacBook, right? You can see that file3 has just been created. Okay, so this is a way that we can share the files with the actual container, running container, and this is called a volume. Okay, so definitely play around with all of these tools. These are just ways that we can do networking and sharing files into our container. So I think this is really all I want to talk about here. I hope everyone can see kind of the relationship between our last video and what we're doing here. Okay, so thank you for watching. I will see you guys